Hello. Today we're going to talk about linear equations and their applications. So very quickly, a linear equation of one variable is just any algebraic expression that can be written as ax plus b equals 0 for some form, right? Common examples would be like 12x minus 3 equals 0, 14x minus 7 equals 21. Right? They don't always necessarily have to be 0, but anytime we deal with something like this, like a linear equation, we need an x to the first term, or really we just think about it as an x term, right? So again, just some more examples. 5x plus 3 is equal to 23, or something like this, right? That may be a little bit more complicated, like 5 is equal to 10 times the quantity x minus 3. Right? So these are just some examples of linear equations. And so when we talk about how to solve these linear equations, we get the normal things, right? This first property, the addition property, just says we're allowed to add anything to both sides, right? The subtraction property says we're allowed to subtract anything to both sides, right? The multiplication property says we can multiply anything by both sides, and the division property says we can divide anything into both sides as long as what we divide is not 0. Right? And lastly, we have a substitution property that says something like if A is equal to B, then we can replace that into any statement without changing the truth or value of our statement. Right? So we can actually solve these problems here, right? If we want to look at the first one, 5x plus 3 is equal to 23. We can use the property of saying, well, how would I solve this for x, right? Typically, the instructions will be solve for x, right? So clearly, we want to subtract 3 from both sides. We'll get 5x is equal to 20. I'll divide both sides by 5, and I'll get x is equal to 4, right? And that is going to be my answer. If we look at our second example, 5 is equal to 10 times the quantity x minus 3. Again, I want to solve for x, and I want to say, okay, how can I simplify this? How can I start to solve this? And we always have to keep in mind our order of operations, PEMDAS, right? So the first thing we see is parentheses. So we say, can I simplify anything in this parentheses? And no, I really can't simplify that parentheses. I can't combine an x and a 3 like that. So then I look and I say, well, what's the next thing I can do, right? It's that multiplication, right? I can take that 10 and distribute it. So my next line should be 5 is equal to 10x minus 30. Right? And now we go along using the additive property, multiplication property, all those properties we saw before. We're going to add 30 to both sides, right? And we'll get 35 is equal to 10x. I'll divide both sides by 10, right? And what we can say is, well, we can take a 5 out of both of these, and we get as an answer 7/2 is equal to x. And that is going to be our answer for that. So those are just a quick examples of how we can solve linear equations. What if we want to solve applications like word problems, right? So the first and most important thing really is to read the problem and draw a picture if we can, right? If we have a geometric standard problem, then it might be easy to draw, right? The third, it was kind of an unremembered one, is we want to assign a variable x, right? After all, this is really an algebra class, and x is really the fundamental symbol of algebra. So we want to represent the main unknown as x, and then represent all others in terms of x. And we want to look for formulas that might be described in the problem to connect these two, right? We want to form that equation, solve the equation, and lastly, we want to make sure we answer the question. Right? That might seem like a repetitive set of instructions, but commonly what happens is the solution we get may not be exactly the form of the question. So what we're actually going to want to do is make sure we've actually answered the question. So let's take an example, right? We want to find 4 consecutive even integers, so the sum of the first 3 is 8 more than the fourth, right? So what would that look like? I want 4 consecutive even integers. So for me, if I want to find an even integer, I can let the first one be x, right? That's going to be my first. What's my second even integer going to be then? Well, like we said before, I want to pose this as a version of x. So if x is my first even integer, my next even integer has to be 2 away from that, x plus 2, right? My third even integer has to be 2 more than that, and my last even integer has to be 2 more than that, right? So these are going to be my consecutive even integers. And so I want to look for a way, or look for a formula that might be written in the problem that connects them. And so we get the sum of the first 3 is 8 more than the fourth. So I'd say, okay, what is the sum of the first 3? That would be x plus 2 plus x plus 4, right? That's the sum of the first 3, right? That is 8 more than the fourth, x plus 6, right? And now we have a linear equation, right? We've taken our English, the word problem, and converted it into an equation. Now we can actually solve this, right? We'll get x. There's really no need for these parentheses. Same thing here. I'm not subtracting or multiplying, so I can just drop the parentheses. Now I can look to add like terms, right? I have 3x plus 6 is equal to x plus 14. Right? I'll subtract an x from both sides. 2x plus 6 is equal to 14. I'll subtract a 6, and then move it over here. 2x is equal to 8. X is equal to 4. Right? And so the question is, have we answered the question? Right? The question wanted the 4 consecutive even integers. I don't quite have the 4, so I just need to make sure I answer the actual question. So it wants the 4 even integers, so my solution is 4, 6, 8, and 10. Right? I've gotten my solution and put it in the form that actually answers the question. All right? Let's look at one more example. So an excursion takes 1.5 times as long to go 360 miles up a river as it does to return. The boat cruises 15 miles per hour in still water. What's the rate of the current? Right? So this is actually a little geometric, right? So let's say the river is flowing in this direction, right? And the total distance it takes is 360 miles. So the boat, the time up is 1.5 times the time down. So that's a good equation, but what we want to do is try and think of how we can start to link these things together. And so there is one big formula we want to know, which is rate times time is equal to distance, right? That is kind of a big, important formula to know. Right, but in this case, since we're dealing with time, we want to rewrite this as to time is equal to distance over r. And so what we want to come up with is 2 time equations, one for up and one for down. Right? So let's work on time up. Right? The distance is still the same. It's the 360. But if you're going up the current, you're going against it. So the rate at which you're going to go is going to be 15 miles minus the rate of the current. And the time down the river is still going to be the same 360, but your rate is going to be 15 plus the rate of the river. Okay? And so these are the times that we can have. And we can use that substitution property right here that says if we have two values that are actually equal, we can replace them, right? This time up is really the same value here. So what I can do is I can replace that in this equation. So I can have 360 over 15 minus r is equal to 1.5. And I'll take this quantity and replace it with time down. 360 over 15 plus r. Now I have my linear equation. I can solve this for r, right? I want to use my PEMDAS. I can't really do anything on the left side, but I can distribute or multiply this 1.5 times 360. If we do that arithmetic, we'll get 540 plus r, right? Now we have two fractions that are equal. And if we want to simplify two fractions that are equal, the best thing to do is going to be to cross multiply, right? So we'll get 360 times 15 plus r is equal to 540, 15 minus r. Minus r. All right, we'll continue. Now we want to distribute this 360. If we do that arithmetic, we'll get 5,400 plus 360r is equal to 8,100 minus 540r. Right? And now we have just a regular kind of linear equation. These numbers might be a little bit bigger, but we still keep the same idea. We're going to add 540r to both sides. Right? 5,400 plus this will be 900r is equal to 8,100. We'll subtract 5,400 from both sides. Right? If we do that arithmetic, 900r is equal to 2,700. And now I want to divide by 900. And as a final answer, I'll get 3 miles per hour. And that is going to be the rate of the current. All right? I hope you guys found this informative, and I will see you in class.